or currently all the manned space missions of China.
Yes. So we can see that the Shenzhou 21 crew is watching the live coverage.
Yes.
Now all the arms have been rolled out. 30 seconds. 20
seconds to go. 7, 6, 5, 4, 3, 2, 1. Ignite. Now the carrier rocket, along with the Shenzhou 22 spacecraft, is lifting off from Jiuquan Satellite Launch Center in northwest China.
And the next critical step will be the pitch over, which means that it will change its direction from the vertical direction to
a certain angle.
Eastern route.
And we can see live footage from within the China space station, or the Tiangong.
So this is video from the camera mounted on the launch vehicle looking backwards. We can see two of the boosters. Each have a rocket engine with a thrust of 75 tons.
Each have 75 tons, and together they
each
have 300.
One rocket engine with a thrust of 75 tons.
So together, can we just add them up?
Totally, they have 8 engines, including 4 on the core stage. So the next step will be the jettisoning of the emergency escape tower.
So even if it's unmanned, it still needs an escape tower at very top.
The key point is we don't want to change its status.
Right.
So any change of the status, although it's unmanned, but still the change of status which means
change everything.
Which means the risk.
Will change everything because it's a very intact system.
The change of everything may cause the problem of other systems.
Exactly. So now it's changing its course. Just as you mentioned, as changing to an eastward course?
Yeah, exactly.
This is still optical, right?
This is a video camera in visible light.
Right.
So because you know that the weather today is really clear. So we can see that the emergency escape tower has already been successfully jettisoned. Also announced by the ground. And the next critical step will be separation of the 4 rocket boosters. About 3 minutes after liftoff. So
how high is this rocket right now? As you just said, it's going to jettison the boosters.
I believe that at this moment it's already supersonic, and maybe 10 kilometers, more than 10 kilometers.
And from this...
this is an infrared image.
Infrared on the right-hand side.
The 4 boosters jettisoned very successfully. And so next will be also the first core stage is already separated. So now is work of the second stage. For the second stage, we have one main engine with a thrust about 80 tons, which have the similar configuration of the first stage, but a vacuum version. And also, we have 4 vernier engines to change its direction and attitude. And for the next critical step will be the separation of the payload fairing, which will happen within several seconds. So this is a camera inside the payload fairing. We can see the folded solar panels,
right?
Yeah. So the fairing separated. Oh, great. We can see that the sky is already very dark, which means that it's already outside the atmosphere. And the second stage, the main engine will work much longer than the first stage. So on left of the screen, we can see the video camera mounted on the tail of our second stage.
So we can see the main engine.
Exactly. And
also, we can see the
one of the small
veering.
vernier engine. So it can be well monitored.
Veering engine.
So it can be well monitored. So now is work of the second stage. For the next critical step will be the separation of the payload fairing, which will happen within several seconds. So this is a camera inside the payload fairing. We can see the folded solar panels. Yeah. So the
And the image quality is really, really high. Every detail is so clear.
That's what I meant. Thanks to our TT and C system,
right?
Both the ground stations and our Tianlian data relay satellite, we can have this high definition video.
Yeah, you can tell every detail, and that's crucial for monitoring, right? You can tell what's going on.
You should remember it's in vacuum condition.
Yeah.
So the temperature. Oh, we can see the beautiful shock wave of the.
就收控制台结束。未来飞船双补完成。
We just heard voice that the ground station has just captured and established the communication link with the flying object.
So what caused that spheric halo we just see?
Yeah, the arc shock wave is the cause. This is a phenomenon caused by the reaction of its flame and also the atmosphere.
Right.
But if in even the dawn or during the twilight, you can see more beautiful vision of this.
Right.
We can see on the top right of the screen is a 3D animation. Although it is an animation, but it's driven by the real date, which means that it represents the real position, attitude, velocity of the launch vehicle.
Right. Still monitoring the main engine right now.
Yeah.
So there are 4 veering engines.
4 vernier engines.
Yeah.
So the main engine is fixed. So it cannot rotating, but the 4 vernier engines can change its direction. Okay, Qingdao station has already captured our launch vehicle because that Qingdao is located in the eastern coast of China.
Right.
So it will be the last ground station for the launch procedure.
And then
you can see the rotating of our vernier engine.
Right. So that also means the report back of Qingdao station means so far it goes right on course.
Exactly. You can see the bright horizon of the beautiful Earth.
Right.
And you may notice that the sky is already very dark. It's black. So it means that this is already outside the atmosphere. You can see our Shenzhou 21 crew is very relaxed, watching the live coverage of CMG.
Yeah.
So thanks to our communication system, every time during the launch of Shenzhou or Tianzhou, our crew in orbit can watch the live coverage.
USB 雷达跟踪正常，遥测信号正常，东风飞行正常。
So everything's
normal. The ground
staff
announced that everything goes okay. And as you mentioned, the reader, the optical devices monitor the spacecraft very normal. And the next critical step will be MECO, or main engine cutoff.
So the main engine is kind of the longest lasting component from the carrier
the second stage only have 1 main engine, so it works much longer than the first stage, and to reach the first cosmic velocity.
Right.
But after the cutoff of the main engine, the 4 vernier engines will work longer, which can not only adjust the attitude of our spacecraft. Oh, main engine cutoff.
2级主机关机。 2级主机关机。
It is announced by the ground staff.
Yeah.
And the 4 vernier engines will work longer to adjust the trajectory very precisely to ensure, as I mentioned, that the orbit is accurate enough.
And the spacecraft itself has an engine system.
Exactly.
Right. It can
for the rendezvous
itself.
and the docking, mainly based on the propulsion system of our Shenzhou spacecraft.
So just to make sure, it's not like this carrier rocket sending the spacecraft right onto
not
the
directly to our space station.
But it sends to a certain orbit, and it rotates. Initial orbit.
Yeah.
Then it rotates.
It's lower than its target, so it can chase our target, the Tiangong space station.
Still on the first cosmic velocity?
Yeah, exactly.
Okay.
Similar.
And eventually it will get to a higher orbit.
Yeah. Usually we choose a faster rendezvous and docking 3 hours or 6 hours. So just today, our Shenzhou 21 crew will enjoy their fresh food.
Right.
And even the beef or chicken.
Right, right. Hopefully we can enjoy another clip of how the space oven works.
Yeah.
The last time we saw baked chicken wings and beef, right?
Yeah. We have an air fryer.
Yeah.
长江5号发现目标。
长江5号 is the name of our Yuanwang 5 space tracking ship. So it's not just now located in our Pacific Ocean. To have it will be the last ground station for the tracking of the trajectory of our launch vehicle.
So what happens next?
It means that
ground station?
Separated.
Main engine separated.
Yeah. No. The separation of the Shenzhou spacecraft is the second stage. So it's the task of our launch vehicle has completed. Now we can see the camera mounted on the propulsion module of our Shenzhou spacecraft. And the next critical step will be the unfolding of the solar panels. We have 2 solar wings, so we can see one of them.
So that's the source of that's the main source of power supply on the spacecraft.
We can see the beautiful Earth, actually speaking, the Pacific Ocean.
So you can actually tell that is the Pacific Ocean.
Yeah.
That's amazing.
各号注意 UTC 0及星力出轨文件会前流程已启动，长城。
And soon the solar panels will be unfolded. So we have 2 solar wings, and each have 4 big panels, which can provide a very powerful electricity for our launch vehicle.
So before the solar panels unfolded, the spacecraft itself, right now at this moment, it's just gliding in space.
It's already in, as I mentioned, in the lower.
It has some kind of basic power supply, or it's kind of total
still,
dark
at this
mode?
moment, it's used a storage battery inside. But after unfolding of the solar panels, they will have a continuous power supply for their electricity. Okay. Still, we can see the cargoes inside our
cabin,
re-entry capsule. But also, not only in the re-entry capsule, in the orbital module, we also have many cargo. As I mentioned, the uploading capability of our new batch from the first one is this Shenzhou 22 spacecraft is much greater than the previous batch.
So what is considered to be additional extra payload for the Tiangong space station? What's the payload capacity for the space station itself? Oh, it's unfolding. Yeah, the solar panels are unfolding.
Yeah.
东风收到。
So this is the last critical step for the launch procedure. But still, we cannot announce the success because you know that at this right moment, we must judge whether the orbital parameters is accurate or not. Only it's accurate enough, we can say it is a successful launch.
Right. So, as you just mentioned, there are 4 such solar panels. Two such solar.
Each with 4 panels.
Each with 4 panels.
Yeah.
So we can actually, from this camera angle, we can see one, and there's another one.
And still, it's in the sunshine area. We can see the beautiful view of the Pacific Ocean, although it's full of clouds. Because you know that the Shenzhou spacecraft orbiting the Earth in the first cosmic velocity more than 7.7 kilometers per second. So you can see that the Earth is also moving very fast in this video.
Right. Still, the taikonauts are watching the live coverage. Huh?
Exactly.
So the data link is super stable and strong. It must be.
Yeah, very, very stable. So I believe that this moment we both have the video maybe from the Changjiang 5 or the Yuanwang 5, the space tracking ship, or from Tianlian data relay satellite.
Right.
At this moment, we already have 2 generations Tianlian, the Tianlian 1 system and the Tianlian 2 constellation.
And actually, all the live footages we're seeing now from space are due to this Tianlian data link.
Yeah. The Tianlian, the second generation, has two very huge antennas. We can monitor different spacecraft.
And still, from this space footage, we can still see the definition is really, really high.
Yeah.
You can see the tiny details on those wirings and all those components.
We just heard that the Changjiang 5 or our Yuanwang 5 space tracking ship monitoring the spacecraft very normal. So as we discussed, still at this moment, we have the communication link between our Shenzhou and the Yuanwang 5.
Right. So far so good. Everything goes according to the plan.
Yeah. So next, within several hours, the propulsion system of our Shenzhou spacecraft will conduct several orbit maneuver and become closer and closer to the Tiangong and finally conducted the docking.
That would also be a phased procedure, right? It's not like just one shot and go. It will be just a step by step, right?
Exactly. Yeah. So we must be closer with different burning of our main engine, maybe sometimes to erase the difference between different orbital planes, some to raise its apogee or perigee, and finally get closer.
Right.
Also, you know that on the front of our Shenzhou spacecraft, we have rendezvous and docking radar and LiDAR, and also optical devices to measure the precise distance, angle, or direction, and also the relative attitude comparing with our Tiangong spacecraft. This time we'll dock to our front docking port, so it's a little bit easier than to the radio docking port.
Yeah, the measurement would be fascinating, isn't it? Because you're not going straight lines. Basically, you're traveling on a sphere, so it's curved. So
yeah,
how would that work?
So you know, we have two different phases. In long distance, usually we have the parameters measured separately. But when we are close enough, for instance, maybe within 200 kilometers, first we can use radio radar. The rendezvous and the docking radar, it can work within a difference of 100 or 200 kilometers. And when it's closer, we can initiate the LiDAR and then use the optical sensors to measure the relative distance. So the guidance methodology is also different.
That's the simulation.
The tracking of our Yuanwang 5 has completed. So this is, as I mentioned, the 3D animation, but it represents the real status of the spacecraft.
Yeah. And this is exactly how the spacecraft looks like in real life or in real space.
It also represents the real attitude, the direction.
And that thin red line we're seeing right now, it's the course, it's the set course, right?
We just heard an important information. The ground staff mentioned that they will now conducting the 4.5-hour fast rendezvous and docking soon, very soon.
根据北京实时轨道与遥测数据监视判断，神舟22号飞船已进入近地点高度200公里，远地点高度369公里，倾角41.5度，周期约1小时30分钟的预定轨道。
Now, the ground control has just announced that the Shenzhou 22 spacecraft has entered the set orbit.
The commander of Beijing Flight Control Center mentioned that the perigee of the Shenzhou spacecraft, or the lowest point, is 200 kilometers.
Right.
And the highest point, or the aperture, is 369 kilometers high. And the inclination, which means that the orbital plane, the angle between the orbital plane and the equator is 41.5 degrees. So it's a very accurate orbit.
It's the set orbit.
When necessary, our Tiangong Space Station can also conduct the orbital maneuver to form an ideal phase, I mean the right position for faster rendezvous and docking. Because you know, for faster rendezvous and docking, it cannot be done every day. Although theoretically speaking, every day we have the launch window, but still, for faster ones, it's more strict.
And this is the live footage from the Beijing Aerospace Command and Control Center.
Yeah.
It's kind of the nerve center for all the space launches and
the chief of the
space
Jiuquan
operations.
Satellite Launch Center will announce the success.
根据火箭飞行数据及北京航天飞行控制中心监视计算，长征2号 F 遥22火箭已将神舟22号飞船准确送入预定轨道，飞船帆板展开，工作正常。我宣布，神舟22号飞船应急发射任务取得圆满成功。
The big red screen.
Yes, the famous big red screen.
Which, so this means the
which
history.
means
we just witnessed of the history. The first emergency launch mission of China.
Yeah, it's not just one of the space launch missions.
Yeah.
It's the first emergency space launch mission of China.
You know that. So we are so exciting. You know how exciting we are because you know the Long March 2F is so complex. We can conduct all the testing procedures within these 16 days and have this very excellent launch today. So
it's super smooth. I would say.
How amazing it is.
Yeah, as a long-time space engineer, tell us more about what you're feeling right now.
Well, really
you're
exciting.
almost in tears.
And
I
also,
have to break it to our audience. You're almost in tears.
Actually speaking, honestly speaking, so we choose the best decision to let the Shenzhou 20 crew return to the Earth with the Shenzhou 21 spacecraft. But just after the undocking procedure, the moment of the leaving of the Shenzhou 21 spacecraft, which leaves the danger to our Shenzhou 21 crew. As we mentioned, they only have a spacecraft with problem left. Although it's better than no rescue ship, but still
it's not the
very,
safest
very
option.
dangerous.
Yeah.
So if anything wrong happened, as we mentioned, if anything wrong happened for a bigger space debris collide with Tiangong and cause a depressurization, so this is the most dangerous situation. We don't have other choices but to leave the station with the Shenzhou 20 spacecraft, although it has a crack on its window, but we don't have other choices. But today, after several hours, with the coming of a Shenzhou 22 spacecraft, our Shenzhou 21 crew will save enough. So that's very exciting moment for us.
Human lives matter the most.
Yeah. Think about it, as we discussed, only 20 days after we found the problem in the 5th of November.
And we finished the whole procedure. And
all these procedures.
Not only by safely getting the Shenzhou 20 crew back on Earth, but also to keep our Shenzhou 21 crew in space safe with an intact spaceship on board the Tiangong space station.
The difficulty is, you know, that for this emergency 16-day mode, you know that all the subsystems, not only the system designers, but all subsystems must complete the gathering within 1 day to Jiuquan Satellite Launch Center and start the testing procedure and all other preparations simultaneously.
Yeah, help our global audience to understand, because you use the technical jargon there, subsystems, because I know that in space engineering it works in systematic engineering, right? So you divide one big mission into subsystems and to put all the missions back together as one.
On the top will be the system of systems.
Yes. So help our global audience understand the massive scale of putting all these huge systems working together in such a short time and achieve success.
For this mission, for this manned mission, we have the engaged in, you know, that the launch pad, the launch site system, actually speaking, the Jiuquan launch site system, the Long March 2F rocket system, the Shenzhou spacecraft system, the astronaut system, the application system, the TT&C system, and also, you know, that the rescue system, you know, that for the emergency escape, we also need the helicopters and other crew, ground staff to find the capsule, although it's unmanned. So this is all the system, and also including the Tiangong space station system. For the subsystems, you know that for the Long March 2F, we have the propulsion system. We have the guidance, navigation, and control system. We have the electricity and other subsystem. And for the Shenzhou spacecraft, also similar. And you know that we must ensure